Welcome everyone to the session of today, the fourth one, actually on Connect University Autumn School, on the topic of secure and sustainable digital infrastructures. I'm Alex and I will be your host for the entire week. But today, merely just warming everyone up for our main topic, the shift to edge data processing, developing a European cloud to edge continuum. We started back in 2015 with Connect University, which is the knowledge sharing flagship initiative of DigiConnect from the European Commission, which aims to update both EU staff as well as you, the general public, on the latest digital trends as well as important digital policies. The scope of our sessions in general is to put at the same table EU institutions, industry, academia, and international organizations, helping us to find inspiration from each other as well as identify current opportunities and threats to policymaking. For those of you who are not yet connected on Sly.do, we invite you to do so, and please use the code EDGENOTES. Over there, I say this because over there you can ask questions, and we will make sure that those questions make their way towards the speakers. Also, we encourage you to use the hashtag Connect University and digital infrastructures if you want to share any insights that you gained today on social media. For the recordings of the sessions, they will be available as of next week, and you can find them both on the Digital EU channel on YouTube, as well as on Futurium on the Connect University space. I invite everyone to join Futurium. It's the place where we can have conversations on all digital topics, and those conversations guide further developments and further events in Connect Universities, and we can see what is important for you at home. Generally speaking, technology moves pretty fast, so we must run alongside with it, and we want to make sure we have access to the most up-to-date information to make sure we reach our destinations in good shape. Before we start our core session of today, I just want to give one small overview of what future destinations we might see this week as well in the Autumn School. Tomorrow morning at 10, we start with a session on data centers. Can growth and greening go together? Hosted by Manuel Mateo Goye, Deputy Head of Unit in DigiConnect Cloud and Software. After lunch at 2, we will begin our session on Web 2 versus Web 3 towards the next generation internet, hosted by Gemma Carolio, Head of Unit in Next Generation Internet. Thursday, we will start again on a more highly technical topic, high performance computing and quantum infrastructure deployment in Europe, hosted by Oscar Diaz, Head of Sector in DigiConnect on Quantum Technologies. After that, we will begin our session on Industrial Platform Economy to Spur Innovation, hosted by Max Lemke, Head of Unit on Internet of Things. And finally, on Friday in the morning, we have the session on mobile generations, 1G to 5G, hosted by Peter Stuckman, Head of Unit in Future Connectivity Systems. And on the last session of the day, Roberto Viola, our General Director, will come and give us a more holistic view of the week, of what happened, the key takeaways from its sessions, and also will give us a small insight into what might happen in the future, what are we looking at in terms of greening, and what is the EU Commission's concern in the area. Now, as for our session on today, the shift to edge data processing, in order to best give a comprehensive context, but also shed some light on the topic for non-experts such as I, but as well as for some of you that might be more fluent in the matter at home, we have with us today Pierre Chastanet, Head of Unit Cloud and Software, Daniele Franceschini, Technology Innovation Standard and IPM Manager at Telecom Italia, Ioannis Picoras, COO Digital Services at Ericsson, the network equipment. Tobias Schuler, Technical Lead for Edge Computing at Siemens. And last but not least, Jean-Philippe de France from Capgemini. So without further ado, please, Pierre, the floor is yours.
Many thanks, Alex, and good afternoon, ladies and gentlemen. It's a real pleasure to be with you this afternoon. For all those of you who are listening to us online, we have really a terrific session in front of us. Alex just presented the set of speakers that will try to enlighten you this afternoon on this fascinating topic of edge technologies. Edge is really a buzzword that is circulating at the moment, but it's more than just a buzz. It's really at the heart of a major shift that is currently happening in the data economy, and that will actually shape the data economy in the coming years. So we're going to be exploring this together this afternoon with a quite diverse panel of experts. We're all coming from European industry, and we will hear different perspectives on edge data processing technologies with experts coming from more the telecom sector, telecom equipment manufacturer, telecom operators, as well as system integrator and industrial system developers. So we have a really great diversity in terms of the panelists that will try to present their different perspective on the development and emergence of these edge data processing technologies, and we will see how that technology can be used to foster the good development of the data economy in Europe. So I will get started myself, and I will share with you a presentation. Give me a second for this. A couple of seconds for this to come up on everyone's screen. Yeah, like it's working. Okay. So I'll get started trying to provide a bit of a broader picture on where the development around edge data processing are fitting in the broader European Commission policies on data. Since the beginning of this mandate, the Commission has been working extensively on the data. This was really the first core priority that was set out in the digital sphere at the beginning of this college mandate. And we issued very early in this Commission a European data strategy. This has been since February 2020 the document that has guided our action, really putting data at the forefront. Why focusing on data? Obviously, data is really the fuel of the digital economy, and has in particular major repercussion on the development of other technologies, artificial intelligence in particular. We wanted to have good development of AI in Europe. You can't have AI providing certain guarantees without having mastery of data, including data infrastructure and mechanism for data sharing. So we set out all these objectives in the data strategy at the very beginning of the mandate. Of course, this came at a moment where Europe was seriously hit by the COVID crisis, and very quickly the European Union responded to this challenge by creating the Recovery and Resilience Facility with the objective to respond to the crisis, but also take the opportunity to modernize the European Union and support the twin digital and green transition. So a significant amount of the RF money was injected in digital technologies, including data processing technology. A bit later in the year, member states came together to say we have a collective endeavor. Cloud and edge technologies represent a major challenge for Europe. None of us will be able to address that challenge on our own, we have to cooperate on those issues. And for that purpose, they signed a declaration for European cloud, factoring in the edge dimension and the need to federate data processing capacities at European level. The Commission pursued its action, and in particular, developing the digital decade strategy, setting a number of key objectives and specific target to achieve this objective to be achieved by the end of this decade, so 2030. In particular, for edge and cloud, we have set out specific targets. The Commission is not naive about the degree of dependency that we have on other parts of the world when it comes to digital technologies. And we thought it was important to analyze those dependencies. This was a key focus of the review of the industrial strategy. And there was a specific staff working document addressing this in May 2021. And we made a further analysis focused on the software aspect that are necessary for cloud and edge technologies at the beginning of 2022. Next slide. This works. Yeah, here it comes. A few words about the European data strategy, just to recall the main pillar of the European data strategy, because it's so important for our action in the data sphere. This is obviously building on previous action that the Commission did on data with the GDPR, with the free flow of non-personal data that ensure that data can circulate freely across the EU. This is a very important foundation of our data economy. But we saw the need to go further on this to create a proper framework to foster the sharing and reuse of data across the economy, notably along industrial value chains to facilitate that industrial actors can share their data with their suppliers, with their customers, possibly with their competitors as well, when there is a market interest to do so. But you need to have a number of governance rules to allow this and stimulate this. So this was one of the key pillars of the data strategy. We also need to invest in data infrastructure and capabilities. So the cloud and edge dimension is very much a focus in this investment pillar. We also need to invest in competencies. That's essential to have the people that can exploit the benefit that data can offer, but it really requires specific skills, so we must invest into those. And finally, we saw the need to pool data, notably on a sectoral basis, and that obviously comes with data infrastructure and capacities. So common European data spaces will be built on these cloud edge capabilities and infrastructure, with the idea again that actors of a certain ecosystem can share their data in such common European data space. I briefly mentioned the digital decade objective, so let's have a quick look at the targets that we set out in the digital decade. We said that by 2030, 10,000 edge nodes will be deployed across the EU by 2030. And we want to have a minimum density of this deployment of edge nodes. So no organization should be further than 100 kilometers away from the nearest edge node. So that's an important factor as well accompanying this target. Secondly, we want to have cloud technologies taken up by all sectors of the European economy, the private sector in particular, where there is still an enormous margin of progression that is possible. So we set out the target to have 3/4 of European enterprises using advanced cloud services by 2030. So of course, different industries will be using different type of technology, and it's therefore very important to foster this integration, to foster the development of what we call a continuum between more centralized cloud capacities and highly distributed edge capacities. How does the European cloud market look like? And I'm focusing purposefully on the cloud because edge is really an emerging market, and it is totally nascent at this stage. We see that the cloud market in Europe, as well as in the rest of the world, has concentrated dramatically over the past few years. But it's continuing to grow at a very rapid pace. So this is also a very good sign that companies are actually moving to the cloud and are driving productivity growth through adoption of cloud technology. We're very happy about that. However, we also see that it's just a handful of cloud service providers that are benefiting from this very rapid growth of the cloud market, and that the share of European cloud service providers is actually declining. So to keep it simple, the pie is getting bigger. The share that European cloud service providers are getting from this pie is getting smaller. So so-called hyperscalers, Amazon Web Services, Microsoft Azure, Google Cloud account for about 2/3 of the market share on the infrastructure and platform as a service market segment. When we look at the biggest European provider, they only account for about 2% in the European market. So we see a bit the asymmetries that are being created in this market. Edge represents clearly an opportunity for everyone, for all market actors, notably to respond to new needs of user industries. So it will provide decentralized computing closer to the user with lower latency. It can remain fully secured and protected, notably when data have to be shared between distributed capacities at the edge and centralized cloud. And we also have to ensure that the entirety of the data processing system will remain sustainable. So energy efficiency of the whole system is absolutely essential. When we talk about edge technologies, we have to consider the value chain of edge computing. And we can see here already the degree of complexity of edge technology. It's encompassing quite a number of facets that are required to deliver an end service. So facilities is very important because it means placing computers, placing a set of servers, typically in locations that are not fit for deployment of computing technologies. I'm thinking the basement of an hospital or a surgery room or along a production line of a factory. So you need to have a place to be able to deploy such edge nodes. Obviously, edge requires some hardware, so you need to have a number of servers that are packed together in a way that is secured physically as well, because this is important to be able to respond to the physical constraint of the environment in which such edge node will be deployed. It also requires a specific chipset to be able to respond to the type of application that will operate on those edge nodes. Connectivity is, of course, essential for edge, notably to foster communication between distributed edge and centralized cloud. Also to have edge-to-edge communication. This is also an increasing trend to build up resilience in edge data processing. So edge nodes can back up each other, can distribute loads among different edge nodes, or in case of failure of one of edge node, that one can take over from the other. So all of this require a high degree of communication and therefore a high degree of networking and connectivity. As you can see, we're talking about a lot of individual data processing capacities, and that requires a bit of coordination, a bit of orchestration, as well as automation, because we don't want individual IT administrator to have to manage this complexity. So this requires a bit of a control plane coming over this to be able to control these different data processing capacities and make best use of the capacities that are available. Then on top of this will come application and software that are deployed in the cloud or at the edge or operate between the two and have software that enables to manage this in a seamless manner. Last but not least, Edge is an enabler. It's a mean. It's not an end by itself. The ultimate objective is to deliver integrated services to the end customer, and this is what comes at the end of the food chain, at the end of the value chain. I will conclude on this. So there are many use cases of edge technologies, and we will explore some of these in the session today. And the key thing that I would like people to remember is that there is not one size fits all. So Edge will allow the deployment of new applications that respond to low latency needs of those novel applications. But the architecture of the system will clearly differ from one type of application to the other. So that will require quite good architecture to be able to respond to the need of different industries, of different sectoral applications. So I will leave it at this for the time being. I'm looking at my colleague if there is time for maybe one or two questions. If question have been in the chat. Okay, just a minute for technical. Okay, so we have a question here. If we use Edge, will we stop using cloud services of Amazon, Google, etc.? So there are different aspects in this question, I think. So Edge can be used standalone. There are certain applications that will just require local data processing, and then processing an Edge node will be sufficient. And there are many other applications that will require this cloud to Edge continuum. So you can think of local data processing of a certain application, let's say for the automotive sector. And every day, some logs of what happened during the day will have to be transferred back into centralized cloud for archiving, for legal reason. So requiring this cloud to edge continuum that I mentioned before. Then, in terms of provider, that's a freedom of choice of the user, and this is one of the key expectations of the emergence of Edge, is that this will bring a lot more diversity in the cloud-to-edge ecosystem. There will be new actors emerging, offering edge services. Some of these edge providers will partner with hyperscalers. Some of them will partner with other type of cloud service providers. So it opens up a whole range of new business models. We're not excluding anyone from the market, but what we believe is that edge technologies will really stimulate competition and will renew competition on the data processing market. Another question, can you give an overview of EU native industry in edge server hardware and software, orchestration and configuration? I will not answer directly that question because I think the panelists that we have today in this session actually will exactly present some of the solution that their companies are developing in this sphere. So maybe that's a good opportunity to transition already to the next speaker. And I will pass on the floor to Dr. Ioannis Fikouras from Ericsson, will present the edge development that are taking place within Ericsson.
Thank you very much, Pierre. I'm starting to share. Can you see my slides?
Yes, yeah, they are coming up, yes.
Thank you. So my name is Ioannis Vikouras. I'm a strategic product manager for our cloud native 5G core offering. Today I'm going to talk about the importance of cloud edge and edge computing as a critical factor for the success of 5G. First of all, I would like to, before I go into the material itself, I would like to give you an overview of who Ericsson is for the part of the audience that does not have a telecommunications background. Ericsson indeed is a leading telecommunications vendor. It is one of the companies that has been driving the success of 5G. I'm happy to say today that we have delivered 130 commercially live deployments of 5G that are operating in 56 countries worldwide. Ericsson indeed, of course, is a truly global company doing business in over 180 countries. What I would like to highlight here in particular is that Ericsson is a big investor in technology and R&D, with almost 28,000 people employed globally for the purpose of driving the state of the art. So now I would like to start by giving a scope to the discussion. So cloud indeed is a very important topic, as Pierre very correctly and fully explained. However, cloud means many different things to many different people. I would like to start by pointing out that indeed, of course, cloud has been used in telecommunications for some time, even in previous generations than 5G, but the focus mostly has been on centralized deployments that were operating out of a main data center of a communication service provider. The difference that we see today is with 5G, cloud is moving out to many different locations. So we see the possibility to distribute cloud on the telco edge, which would be still telecom installations, but in a far more distributed manner than the central data centers. But also we see cloud and, of course, 5G services moving also indoors in both enterprise and even the residential facilities. And also we see a potential to deploy an already wide deployment of 5G and edge cloud into various enterprise applications, both in the industrial sector, but also related to consumers. One example maybe that many people can relate to is autonomous driving. So I will try to cover various, in this presentation, I will try to cover various of these aspects and give you a broad view of how cloud is deployed in different contexts of edge. Now, before, however, I go into the details of how cloud is driving and help to make 5G successful, I would like to start by giving an overview of how the value chain and related technologies look like before 5G in 4G. Of course, 4G is what we all use today. It is what is driving our smartphones and what is enable us to use all sorts of modern services everywhere, ubiquitously on the go. Now, in 4G, the value chain was a fair bit simpler, as you will see also later on in the presentation. So we have mainly three players: technology providers, service providers, and application providers. The technology providers focusing on providing products and services to telecommunications service providers to help build and maintain their networks. The communication service providers, of course, providing the connectivity services to consumers, enterprises, and other public services to drive all these modern services that we use today. And finally, we have over-the-top application providers such as social media and other kind of smartphone apps that you, of course, all are familiar with, that are using this connectivity to provide useful features to consumers, enterprises, and also public services. And this value chain has been cooperating on the basis of interoperability and open standards, also a lot of open source, I would like to point out, in order to create a total result. That is basically the telecommunication services that we use today. Now going forward in 5G, now this picture is getting a bit more complex. We still have, of course, the same players, but we also have new players, and we also have, through the impact of cloud, completely new relationships coming up. So in this context, of course, on the one hand, the new promise I should explain of 5G is that not only can we use all the services that we have been using so far, in fact, in a much better way, with faster connectivity, more reliably, with better quality, but also the introduction of many new services that will be have been futuristic so far, but are becoming very rapidly reality. It will be centering around the digitalization of many vertical industries and enabling their products to benefit from connectivity and basically provide new benefits to consumers and enterprises. So the change that cloud is driving here starts, first of all, on the technology provider level. Companies such as Ericsson, they now evolve to offer not only the traditional network functions, but also cloud infrastructure. And of course, they continue to collaborate with communication service providers in bringing these components together, the technology together with the operations in terms of creating systems and operating systems that can be used to provide services to consumers and enterprises. The communication service providers also evolve to make use of these cloud technologies, and their purpose here and the need is to lower TCO and to increase flexibility toward new types of services. And of course, they also are moving to different customer segments, as discussed before, to address new enterprise needs. The enterprises, of course, themselves, they are digitizing their business processes, and of course, they're benefiting from the functionalities enabled by connectivity and 5G in many different ways, as you're all familiar with. Last but not least, the biggest impact here is that the public cloud providers enter the market as vertically integrated players. Vertically integrated in the sense that they start by producing on hardware, developing on cloud technology and also application technologies as de facto standards, and offering also services directly to consumers and enterprises, also public services globally. Now, on the one hand, of course, the value chain continues to exist and continues to provide services based on an interoperable stack and open standards as much as before. And that is the basis of the success of 5G. However, also for the first time, we see market participants here consolidating several steps of the value chain and using this consolidation to offer services directly to consumers and to other customers. So going a bit more into the details, now what is Edge Cloud specifically? Edge Cloud can also comes in different flavors. Now, of course, as I mentioned before, telecommunication service providers have been already using cloud technology in the past to drive their centralized data centers. That helps them to, of course, to lower cost, increase flexibility by managing computing and storage resources spread out over a multitude of infrastructures. However, also now what we see in 5G coming up is that the network functions also become cloud native, and their management also is further simplified on this cloud infrastructure, and also that edge resources now can be managed in the same manner. So basically, this helps communication service providers to move also into the telco cloud edge. But also we see enterprises moving in, deploying cloud on-premise, which is can also help them on their side to manage computing storage resources that are disparate in many ways, and also to make sure that they can be also leveraged to potentially drive telecommunications use cases on premise. And then, of course, finally, we have public cloud now coming in that is also offering an alternative possibility, helping customers to focus on their core business and lower total cost of ownership by using public cloud services instead. And also, I would like to point out here, we see that edge resources also can be offered, can be provided by public cloud providers as well. And that can be either take the form of co-location sites or actually also public cloud capacity as such. So all of these three cases constitute potential relevant use cases for cloud edge and 5G deployment. Now, Ericsson itself is addressing all of these possibilities in terms of edge cloud. So I would like to start from the top with by discussing service orchestration. Service orchestration is a fairly high-level function that drives the interconnection of application ecosystems and efficient management of workloads, acceleration of delivery of services, and automation of end-to-end service deployment and network slicing. Network slicing is a very important telecommunications use case in the context of cloud, and in particular edge cloud, that enables a new slice or a new instance of a core network to be deployed on a cloud infrastructure, for example, on the edge, that this can be used to serve specific telecommunications need, for example, in order to provide specific capabilities on premise for a particular enterprise use case. Then, of course, network exposure is a very important parameter here. So in the context of 5G and also the context of digitalization of various vertical enterprise use cases, it becomes increasingly important to integrate a developer community that has limited telecom competence and to address their specific needs. So network exposure is the technical capability of providing appropriate APIs, not only in the technical sense, but also in terms of usability, in terms of the knowledge needed to use these and consume these APIs to such developers in order to promote and facilitate the integration of communication services into various kinds of applications. Then, of course, we have connectivity itself, and here we come in with two different improvements. One related to routing data to the nearest edge location. Now, without going into too many complex details, there are many use cases that require the specific routing of data to a particular physical location. That can be both for security reasons, for regulatory reasons, or also for, most importantly, most commonly for latency-related reasons, in terms of delivering a more appropriate customer experience, but also user plane on the edge, which also means that data connectivity can be guaranteed to be delivered through a particular edge location, which again can further help to reduce latency in terms of implementing a particular data breakout to a particular location. All of these are critical capabilities for the success of edge computing and 5G. Last but not least, of course, the cloud layer itself comes into play. So the actual software that actually enables the management of the hardware in this flexible way that enables cloud-native applications, both for compute and storage, is also part of the spectrum that we discussed, and is obviously the foundation for all the other improvements. So this concludes the overview from my side. Thank you very much. Are there any questions?
Okay, so thank you very much, Ioannis, for this very comprehensive presentation. I think it shows very well the degree of convergence that exists between connectivity, telecom, the telecom world, and the data processing world. Someone was asking what is different to Ericsson for cloud compared to 10 years ago? What has changed?
Yeah, if I may go back to one of these slides, I think you can see here in these slides very clearly the difference. In the past, the level of complexity was fairly low, with the telecommunications service providers basically buying whole systems from Ericsson, hardware and software that would actually perform a particular function, fully integrated. Now this is moving away from that. There is a significant disaggregation where we now see that the hardware is separated, and to some degree common off-the-shelf hardware is used for certain, in particular in the core network, maybe not so much in the radio, but in the core network at least. And we have also obviously cloud technology coming in that helps to unify all this disparate hardware infrastructure, both in the center and in the edge. So this creates a very big difference, both in terms of obviously the scope of the products, but also in the ways of working. There's a lot of new tasks that come in terms of verification. The verification itself becomes much more complex and much more important, because now we have products coming in on many different layers from many different suppliers that can also be combined in many different ways that were not possible before. And all of that obviously needs to be verified. And obviously, in developing these technologies, all of that diversity needs to be taken into account as well. So I think that is a very big difference. And obviously, going forward with the adoption of cloud more strongly, this divergence will be strengthened, and the need for greater, let's say, coordination will be even more important in the future.
Yes, many thanks for this, Ioannis. There is another question pertaining to the sustainability aspect. Obviously, this edge is going to drastically change the architecture of system. How do you see it from the Ericsson perspective? How can we maintain a high degree of energy efficiency in these more complex systems?
Yes, of course. I mean, this is an area where we see great opportunities. We have been driving one example I can mention is we have been driving the development of technology towards the greater use of hardware acceleration, which can enable us to achieve greater performance, both with lower cost and lower power consumption, even in fact with a smaller physical footprint. So there is great potential here to improve the performance of the networks and reduce the power consumption needed.
Okay, very good. Thanks a lot. I think this sustainability dimension is indeed a very important factor we must keep in mind as we want to foster this digital transformation in an energy efficient, in a green manner. So thank you very much for enlightening us on this. Thank you for all your insights. I think there was really content for everyone, for the novice as for the experts. So thank you very much for your respective perspective on this. We're going to be breaking now for a few minutes. We reconvene at 15:15 sharp, and we will hear from Tobias Schwele from Siemens. Many thanks, and see you in a few minutes. Many thanks.
Many thanks.
Thank you.
Hello, good afternoon, and welcome back to this Connect University session on the shift to edge data processing. I'm Pierre Chassanet. I'm the head of unit DG Connect, in charge of cloud and software. And we're looking today at this major trend and actually its actual realization, the move of data processing capacities closer to the user, closer to where data are being generated or collected. So that's what is called the edge data processing. We have a number of prominent industrial companies who are working in this area today with us. We heard in the first part of the session from the perspective of Ericsson and Telecom Italia. And in the second part of the session, we're going to hear the industrial perspective of Siemens and the perspective of a system integrator, Capgemini. Let's start with Tobias Schüle from Siemens Technology. Tobias will present the perspective of Siemens on this topic. Tobias, the floor is yours.
Yeah, thank you very much, Pierre, for the kind introduction and for having me. It's a pleasure to be here today. So let me share my screen. I hope you can see it now.
It's coming up. Give it a minute. It's going to come up. We can see your browser at the.
Not the slides.
Not the slides, no.
Okay, I'm sorry for that.
It's coming up and we can see it perfectly. Yes, it works.
Great. Sorry. Yeah, let me start right away with some numbers about the data volume generated by our products. That list is certainly not complete, but I hope it gives you an impression. So, for example, a gas turbine generates about 30 gigabytes per day. A computer tomograph, 60 gigabytes. The controllers, which are used at CERN, 100 gigabytes. And that does not include the detectors themselves, which generate way more data. And if you even have some live video streams, for example, that can easily sum up to multiple terabytes per day. On the right-hand side, you can see another example. This is an application for machine tooling. Typically, these kinds of devices have about 3 million sensor values per hour, which sums up to roughly 2 gigabytes per hour. And I think it's pretty obvious that sending all that data to the cloud is simply not feasible. And this is where edge computing comes into play. In that edge computing kind of bridges the gap between the field level and the cloud. At least to my knowledge, there's no common definition of what edge computing means, but in the previous talks we have already gained a very good understanding. Let me try to explain a bit what we understand when we talk about edge computing. So there are a couple of characteristics. One is first and most importantly that edge computing allows you to process large amounts of data locally where the data is generated. Then edge devices are typically remotely managed, meaning that you can configure and update the devices via some central services. Moreover, edge devices are extensible, meaning that you can add additional functionality during the lifetime of the system. Also, there are typically open interfaces for partners and third-party app developers. And last but not least, one typically needs also a technical means for separating critical from non-critical workloads via some sort of hardware or software isolation. Now, what are the benefits? Yeah, I think the most important one is certainly that, as we have already seen previously, that you can process large amounts of data at a high frequency or even in real time. Also, the edge helps to improve security and privacy of sensitive data. And last but not least, it also helps to ensure or to guarantee high availability independently of the cloud connectivity. And the latter two aspects are particularly important from an industrial perspective, for which reason I'd like to say a few more words about that. So what you can see here is an overview of one of our edge solutions for factory automation. Don't worry, I don't want to go into all the details here, but what I would like to point out is that unlike in classical IoT, where you have a sensor, for example, that sends some data directly to the cloud, here we have multiple levels. Yeah? So on the left-hand side, we have the shop floor level with the actual edge devices, which are connected to the data sources, namely the field devices. On the right-hand side, we have the cloud level with marketplaces where you can purchase and download apps. And in between, we have the enterprise level. Yeah? And this enterprise level can be hosted on-premise, because many of our customers want to be independent, in case there are connectivity problems with the cloud, so that the factory, for example, is still operational, and also that allows you to keep sensitive data within the company. So let's have a look at some application domains. So at Siemens, for example, we are using edge computing also in our own factories, for instance, for quality assurance, using visual inspection, for example. Then we have the whole area of diagnostics and failure detection in process control, for instance. Predictive maintenance is definitely one of the key drivers, I would say, for IoT in general. Yeah, the basic idea is that the sooner you detect that a certain part may break, the better, because you can replace it before it breaks and thus avoid costly repairs or even accidents. Then we have the healthcare domain. Especially medical imaging. Here, huge amounts of data are generated, and typically this data is sensitive for obvious reasons, and sometimes there are even regulatory requirements that prevent you from sending that data to the cloud. Condition monitoring in power plants, well, the intention is pretty similar to what we spoke about in the case of predictive maintenance, so detecting anomalies during operation. And last but not least, Edge is also a hot topic in managing smart grids, for example, for collecting data about energy consumption and managing the available assets. So one of the topics for today is sustainability, and what I would like to emphasize is that edge computing can help to increase energy and resource efficiency. So what you can see here, for example, that is an edge-based application that collects data about the energy consumption in a factory. You have different devices here. It's unfortunately a bit hard to read. For example, there's a mixer, a purifier, a boiler, and so on. And as a factory operator, you can see for each of these devices how much energy it consumes. And also there's a visualization of the energy consumption over time. And that gives you, I think that's a good starting point to improve energy consumption and efficiency of the factory. So let's try to have a quick look into the future as far as we can. As Daniele already mentioned in his previous talk, edge computing actually comes in different flavors. Yeah, so the definition I gave before refers to what we call the app edge. Yeah, so this is very similar to what we all know from smartphones. So you have some apps you deploy onto devices, but there are other notions of edge computing as well, like the offloading edge. Yeah, so here the idea is that you transparently distribute different kinds of workloads on one or more edge devices, typically without user interaction. Yeah? And this is used, for example, in hospitals, because the medical staff, they don't think in terms of apps and devices. They want to get their job done, namely analyzing images. Yeah. And the third variant, we call it the service edge. So typically these solutions are highly domain specific, tailored towards certain use cases. Usually you have some pre-integrated applications and protocols. Configuration is done via special engineering tools, but they're not that flexible in most cases as the app edge. Yeah, for this reason, the appropriate technical means are not necessarily available, yeah, like container-based isolation. And so what we expect is that these different kinds of edge platforms will be harmonized in the future and will also become more general and more versatile. Another trend we observe is that the device classes supported by the edge platforms are becoming more broader. So today, when we think about edge computing, we usually have some servers in mind or industrially hardened PCs. But in the future, we will likely see edge functionality even on smallest devices, like a sensor equipped with some microcontrollers, but also at the other end of the scale. So yeah, we will definitely have and already have today edge platforms supporting hyperconverged infrastructure consisting of very powerful servers. Also, we see that the kinds of applications are becoming more and more broad. So it's not only collecting data, pre-processing it. So we have complex applications, for example, for perception and analytics, for digital twins, and even for real-time control. And that goes hand in hand with a number of research and development topics one has to address. On the right-hand side, you can see an excerpt. This list is definitely not complete. So actually, these topics were taken from a white paper published by the Linux Foundation Edge. And for the sake of time, I don't want to discuss all of them in detail, just to mention a few. So mass device provisioning and management is, I would say, one of the cornerstones of IoT and edge solutions. We also see more and more legacy applications side by side together with edge native workloads. Real-time already mentioned briefly, so that has significant impact on the whole software stack. So we need real-time capable operating systems and especially real-time capable networking. And yeah, so mixed criticality workloads on a common infrastructure that goes into a similar direction than what I mentioned concerning legacy workloads. And another topic which we are also having a look at is the use of hardware accelerators for edge AI. Yeah, that brings me to the end of my presentation. To sum up, let us have a quick look at the evolution of the Internet of Things, so to say, at least as we see it from the Siemens perspective. It all started with connecting some legacy devices via IoT gateways to the cloud. Today, we are mainly concerned with edge computing, which allow us to carry out complex applications at the edge. And in the future, we will probably see some sort of collaborative computing environments where you have multiple systems that communicate and interact with each other in order to solve a common problem. Yeah, so that's all from my side. Thank you very much for the attention, and I'll be happy to answer any questions.
Okay, thank you very much, Tobias. I think you have highlighted quite a few important points, and taking up on one question which we didn't have the time to pick up from the earlier session. You were pointing a number of R&D challenges in
yes.
the slide. This is something that I wanted to highlight as well, the fact that this is one area in which the European Commission is investing, trying to foster collaborative R&D across Europe, notably through our Horizon 2020 and now Horizon Europe program. So there are regularly opportunities for European funding stemming from Horizon Europe in this field, with the idea to develop a cloud to edge to IoT continuum. We do have a further question stemming from the first part of your presentation, Tobias.
Yes.
What sort of data sources have you seen increasing most drastically in volume over the past 2-3 years?
I lost the audio now. Can you hear me?
Okay, could you hear the question?
Not really. Sorry, there was some audio problems.
To repeat, I said, which data sources have you seen increasing in volume over the past 2-3 years?
Okay. Which data sources? Yeah, good question. I mean, I think most data generated is increasing over time, but this is particularly true for all kinds of imaging applications. So whenever you have some, let's say, some visual object inspection, some cameras, I mean, these generate large amounts of data. For which you definitely need computing power at the edge. I hope that answers the question.
Yeah, indeed. We largely share that perspective. So thanks a lot for this. We've been focusing a lot on the highly distributed part, and you rightfully mentioned at the end the IoT dimension with increased data processing capacities developed in IoT devices. What about the other way around, in much more centralized capacity, HPC notably? So how do you see the integration of HPC technologies with the rest of cloud edge data processing continuum?
Yeah, good point. I think we can learn a lot from the HPC area. And as I already mentioned, so edge computing is evolving towards smaller or even larger clusters. And for that purpose, we definitely need technologies used for decades in the HPC area, for analyzing complex data. So I think there are definitely a number of synergies when edge computing is advancing towards more parallelism.
Okay, yes, the hardware parallelism, and I think you were actually hinting at this in with your description of the hyperconverged infrastructure.
Exactly. Yeah.
Okay, very good. Thank you very much, Tobias. Really much appreciated your presentation. So I propose we move on to our last but not least speaker, Jean-Philippe de France from Capgemini, who will present the perspective of a system integrator. Jean-Philippe, the floor is yours.
Thank you. I hope you can hear me correctly. Hello, everyone.
Hello, yes, we can hear you properly, yes.
Okay, so share my screen. So my name is Jean-Philippe de France. I'm Vice President of the Edge Strategy, Go-to-Market and Operations at Capgemini. And hopefully you see the slides on full screen.
Yeah, that's good, yes.
Okay. So today I would like to share with you our point of view on edge computing. And as you see, it's very related to the intelligent industry, just like it was introduced by Siemens in the previous presentation. Actually, before I dive into edge computing, I would like to briefly speak about Capgemini. We are a large and very well-known company, but there has been an important change that is related to edge computing in a way. Many of you might know us as a service integrator. So might know us as a service integrator or for our consulting activities. And one of the key changes in the recent years is the introduction of engineering. And it provides us now with different end-to-end capabilities. And you can see the term unlocking the value of technology. Because today Capgemini can drastically change the experience, whether it's your personal experience of technology or your professional experience, for instance, on the shop floor, reimagining that experience and engineering not only the application, but also the physical devices up to applications which are running at the edge and the cloud. So it's an important change because it really provides us the ability to address the full value chain from a service standpoint. I would like also to mention that we do that with a key focus on sustainability, which is one of the key initiatives that we've launched within the last 2 years. And that's important because for us, edge computing, it's not just about infrastructure. Yes, we will discuss today a platform, and it is indeed at its very core technology. But we see that as a paradigm shift in the same way that cloud introduced a shift many years ago. And what I mean by that is that it's not about introducing a new piece of technology. It's about reimagining the experience and making the best of the distributed capabilities that we have from a compute, but also from a network standpoint. And this has impact, again, on reimagining the experience, the product that you might use, whether it's your phone or a robot, and how we operate complex processes. So it's not just about infrastructure, it's about, again, the full value chain and focusing on the experience of people. Now, if we focus on edge computing, we see that the need for edge computing is definitely growing, and one of the key reasons is that there's innovation that is happening at the edge. So the edge being as close as possible to the end users or to the intelligent devices. So in a sense, it's not just about edge computing, it's also about the new access networks such as 5G. It's about the new type of IoT sensors which are developed. It's about the move to more mobile devices, but also new equipments that are introduced, again, either personally or professionally, such as AR, VR glasses or drones. These technologies, they allow us to build new use cases that we can categorize into 4 big families. One family of metric analytics baselining, basically processing a lot of data to better understand a complex process. So for instance, in factories or traffic where there's both cars, pedestrians. Then the second family, situation event detection, where we move a little bit on the intelligence side with more AI, where it's not just about understanding, but also introducing a feedback loop and interpreting the situation to ensure, for instance, that we avoid collisions between cars and pedestrian, which is linked to the V2X, or that we can prevent any accidents to happen. Then the third family is unmanned remote operation. So it's about the ability to either have an autonomous robot, such as a drone, for instance, or autonomous vehicles, but also the ability to operate them remotely to ensure that we can have a specific operation, an intervention from an expert to operate from a distance. Finally, there is a family of use cases related to augmented and virtual reality, such as assisted maintenance, where you have an expert that is supporting someone that is not an expert and on site to do maintenance operations. Again, it might be on a robot, it might be on an energy installation. And what we see in that all those 4 families of use cases that use, the innovation that is pushed at the edge, is that edge computing in those use cases allow to solve some specific problems, like latency, of course, because the compute capability is closer to the devices and the users, the guaranteed and better bandwidth that the one you might have, for instance, with a very long and complex network architecture, and so on and so forth. I would like to focus actually on 2 of those key characteristics, starting with sovereignty. Indeed, edge computing relies on compute capabilities which are distributed. And this compute capability does not exist today, it has to be deployed. And it provides us with the opportunity to build sovereign compute capabilities, ensuring, for instance, the interoperability of all the different edge nodes using, of course, standards, and ensure that applications are portable to different locations, even across countries. It provides us the ability to process data as close as possible to the users. So also giving us the ability to really meet the requirements of each countries. And also, because it's close to the user, it also provides us, or close to the devices, it also provides us the ability to run operations that are also local, and therefore, again, comply not just from a location standpoint, but also from a regulatory and security standpoint to the need of each country and each organization. So that's the first one of the first key characteristics, and the other, and that's one of the topic for this afternoon, is sustainability. Indeed, deploying new edge nodes across Europe means deploying adding to the carbon footprint across Europe. But we strongly believe that this deployment will allow us to actually reduce the energy consumption, so the carbon footprint of the overall network, provided that, of course, we do the best use of the capabilities which are close to the users, and when it's required that we do the best use of the cloud, for instance, resources. But also, and it was mentioned by Siemens, we do believe that the hardware, when we mention nodes, the edge nodes, they might be very small. And certainly we are going into a direction where we will be different form factors. But what is sure is that they have to be energy efficient because they are limited. They are more limited than the cloud, where you might think there's infinite resources. So by design, they have to provide the ability to use efficiently the resources. And then finally, because it's local, and that's what I mentioned in the sovereignty part, but it's also applicable here, it will provide also the ability to create new use cases, to imagine new use cases which could be more sustainable than the ones that are deployed today and that are yet to invent. Now, this will require, that's part of the ecosystem, that's part of the value chain, that there are efforts on optimizing the hardware itself to ensure that, for instance, the graphic chipsets that we want to use at the edge are still very energy efficient, while also providing the power that is required to run the AI application at the edge. One point in which we also believe a lot is the impact on the intelligent devices themselves. If you take an AR glasses today, you could have the intelligence in the AR glasses, meaning that probably you would have to change your AR glasses a year from now or 2 years from now, just like you are changing phones. But if the intelligence is at the edge, then to update the intelligence of the AR glasses, you just have to update the edge, which is much easier, and you don't have to change your AR glasses. So the lifetime of the AR glasses and therefore will be longer, and therefore its carbon footprint will reduce overall. There will be less waste from those intelligent devices, and that applies actually even to robots in factories. Now, there are a few challenges for edge to be deployed at scale. All right, so these characteristics that I mentioned, whether it's the better latency, more security, the sovereignty and sustainable aspect, they are true, and we can best leverage them if edge is deployed at scale. To do that, we need effort on the whole spectrum of the value chain. It starts with intelligent devices, which can use those edge capabilities and even use the overall continuum from the edge to the cloud in the best way possible. This is not just about the device, it's also, of course, about the applications which are used by those devices or by end users. And therefore, we need a new kind of application that are not just SaaS applications running centrally, but apps which can be run distributed across that continuum. And we have very few today. We also require optimized edge hardware. There's great progress that is made in that direction, but we are still today in a place where hardware, especially if you take graphic cards, we are still evolving the power that big graphic card can have. So certainly in terms of performance, there is still things which can be done. And at the same time, we need to make progress on the energy consumption and form factor of this hardware to ensure that, for instance, we can easily deploy an edge node at a crossroad. Then finally, deploying edge at scale will require connectivity. And communication service providers are in a prime position, especially with the investment in the new distributed networks to deploy those edge nodes. Because once you have your intelligent device that you're using, for instance, in Paris, if you are mobile and you move to another city, if you don't want to lose the service, then you need that coverage. If you want the same quality of service that is, again, using the edge, right? So we need a minimum coverage, just like you need a minimum coverage of the cellular network. So let's say that we have all of that. Across the value chain, all the actors made a great of effort. And I forgot to mention, of course, the service integration that is required to ensure that there is actually an end-to-end solution. Edge computing at scale will offer new challenges that we forgot a little bit because of the cloud more centralized architecture. So you have to manage applications that are across hundreds of nodes. You have to secure them. You have to find the best edge platform, and so on. So it offers new challenges, which will require a new type of solution that we call multi-access edge computing, that has been standardized by ETSI, and that address those challenges, and especially the orchestration of the lifecycle of applications across many edge nodes, but also provide an abstraction layer so that developers don't have to have network knowledge to build very efficient application running at the edge. One use case I would like to briefly mention as an illustration of what we can do with edge computing is smart city traffic management. So in this case, it's about cars and pedestrians at the crossroad and how we can reduce the number of risks. Edge computing as a compute capability alone will allow to solve the issues in terms of near real-time processing or low latency. And as you can see, multi-access edge computing will provide better edge-to-cloud integration, will also provide better integration into the network, ensuring that we can optimize and guarantee the quality of service of the different applications, but will also allow to share the different edge nodes across different actors, whether it's different providers or different software providers. That's it for today. Thank you for your attention, and we'll go now into Q&A.
Okay, many thanks, Jean-Philippe, for this very extensive overview and bringing us a bit closer to the user. Actually, the couple of questions I have for you pertain to this. Could you tell us from your experience which use cases do you see in industry or public sector having the biggest problem in transition to the edge?
So I'm not sure that I would say it's much a problem. I would say that there are business drivers. So, for instance, if you take manufacturing, for instance, that production lines need to be more flexible, while the cost of production needs to go down. And that creates a set of pressure that allow new use cases to emerge. You know, like for instance, what can we do with AGVs? Maybe we can use autonomous vehicles. Let's keep it simple as a whole. Robots that move in the factory, right? What can we do with that to optimize the production line? But this creates new questions, like for instance, worker safety. And overall, then it creates challenges from a technology standpoint that as of today, then we cannot solve actually just relying on cloud technology. And so everything is really coming from business drivers and new use cases which are emerging. I've listed a few in the introduction, but I truly believe that we are at the start the identification of those new use cases. We do have a lot in manufacturing because edge computing is actually already used a lot in that context. But there are others, like for instance in energy optimizations with smart grids, and that's a very interesting use case as well.
Okay, thanks a lot, Jean-Philippe. The second question was a bit of a corollary to this on the sort of challenges that you see in the industry in implementing these sort of smart, intelligent devices in the edge. So I think you've answered that already in the case of manufacturing, unless you want to bring something else.
Well, I think one of the key points is to best use edge computing. Of course, you need connectivity that will allow to make the best use of edge computing. And of course, it means evolving the way devices are connected, which, for instance, if you take manufacturing and the new possibilities of 5G, will probably still take at least 2 to 3 years. So that it's the new normal, right? We already are trialing that. So that's one of the key challenges, definitely that connectivity to make the best use of what we will be able to do at the edge.
Okay, that's very clear. Thanks a lot, Jean-Philippe. We're just a couple minutes before we have to close the session. So thanks a lot for all your insights. I think there was a bit of a common thread across your different presentation on the need to integrate so many components and aspects to deliver the promises of edge data processing. So the complexity of the value chain of edge data processing seems immense. Integrating the hardware dimension, the network and connectivity, the smart middleware platform that are required to operate, orchestrate these distributed edge nodes, the distributed application, of course, to manage them and operate them, and more importantly, to make the service available to the user, seems a key endeavor for all your companies. So, of course, there is this complexity to manage, but at the same time, there are enormous benefits of bringing application with very low latency, with high responsiveness, close to the user, with a sense for the user that they are more in control of the data that they are generating or creating. So I would like to thank all our 4 speakers, Ioannis, Daniele, Tobias, Jean-Philippe. Thank you so much for making yourself available today and enlightening us on the development of edge technologies in your respective organization. Many thanks to our host today, Alex. Thank you so much for organizing this event for us. Thank you very much to the Connect web conferencing team who is behind the curtains, but is ensuring that this event can be web streamed to so many colleagues. And last but not least, I really would like to thank my colleague Ana Juan Ferrer, who has been organizing this session and has developed the narrative, invited found and invited all the speakers that you heard today. So many thanks to everyone. Last but not least, many thanks to all of you in the audience. Thank you for the interaction, all the questions you've been raising, and looking forward to hearing from you in the upcoming Connect University session. Have a great afternoon and see you soon.
Yes, thank you. Thank you, everyone. I hope everyone got the insights they wanted. And we gladly wait for everyone tomorrow and Thursday and Friday, but tomorrow on the sessions on data centers and on Web3. Thank you very much and have a great afternoon.